Our topic is atomic structure. We know that an atom consists of subatomic particles like protons, neutrons, and electrons. The arrangement of these inside the atom is known as atomic structure or structure of an atom. There are many theories and models were proposed by various scientists. Out of that, one of the most important model is known as Bohr atomic model. We are going to discuss about that. In Bohr atomic model, in an atom, electrons are arranged in various shells around the nucleus, and they are filled in the increasing order of energy, as shown in figure, like in a planetary system, where planets revolve around the sun. Here, electrons revolve around the nucleus. The nucleus consists of protons and neutrons. Around that, electrons revolve around in particular shells, and shells consist of orbits where electrons are occupied. This is the concept of Bohr atom model. Electrons are considered as particles here. We can see various shells 1, 2, 3, etc. The shells are arranged in the increasing order of energy. So the electrons will fill the lowest energy shells, then the next energy shells, and then to the highest energy shells. This is the Bohr atomic model in a nutshell. But later, a lot of drawbacks of this model was found out. So modern theories revised this model and made some additional arrangements or additional models, added some revisions on this model. One of that is a wave mechanical model. According to this model, electron is considered to exhibit both wave-like and particle-like characteristics. In the original Bohr model, electron was considered as a particle. But according to this model, wave mechanical model, electron is considered as a particle as well as a wave. In this model, an electron is no longer treated as a particle moving in a discrete orbital, but rather position is considered to be the probability of an electron's being at various locations around the nucleus. That means we cannot predict where exactly an electron around the nucleus according to this model, but we can have a probability distribution. We have a probability distribution. According to that, we will predict this much probability is there for a particular electron to be in this position. Okay, so that is the wave mechanical model. In this model, some concepts are there that we are going to discuss. First concept is shell and subshell. We know that around the nucleus, shells are there and electrons are seen inside the shells. And the shells are specified by principal quantum number small n, which may take integral values beginning with unity. These shells are designated by letters K, L, M, N, and so on, which corresponds to first shell, second shell, third shell, fourth shell, fifth shell, etc. Okay, so shells can be represented by the numbers 1, 2, 3, 4, 5, etc., or the letters, capital letters K, L, M, N, O, etc. And again, each shell is subdivided into subshells. Okay, so inside the shell there are subshells, which are denoted by lowercase letters such as S, P, D, or F. And each of these letters represent the shape of the subshell. For example, S has got a spherical shape, P has got a dumbbell shape, and D and F has got some complicated shapes. In these subshells, there are regions where there is a high probability of finding electrons, and these are known as orbitals. So these subshells, inside the subshells, there are orbitals. Inside these orbitals, the probability of finding the electron is very high. So electrons can be found out in these orbitals. And the number of orbitals in S, P, D, and F are 1, 3, 5 and 7 respectively. So in S orbital, S subshell 1 orbital, P subshell 3 orbital, D subshell 5 orbital and F subshell 7 orbital. And the maximum number of electrons that can be accommodated in an orbital is 2. So in an orbital, maximum only 2 electrons can be accommodated. So these are the subshells present in each shell. The shell number 1, only one subshell, that is S. And subshell S and P are present in shell number 2 and 3, S, P and D, and shell number 4, S, P, D and F. That means number of shells in a particular subshells in a particular shell depends on the shell number. You can see shell number 1, 1 subshell, shell number 2, 2 subshells, that is S and P, and shell number 3, 3 subshells, like that. So the number of subshell in a shell depends on the shell number. Also the shell numbers 1, 2, 3 and 4 have names K, L, M and N that we have seen earlier. So next we will study the representation of subshells in each shell. We know that S subshell is present in all the shells 1, 2, 3 and 4. So how this S can be represented when it comes in various shells, that is shown here. Or P, when it comes in various shell, how it is represented. Some examples are shown in this table, and other things which are to be filled, we will fill soon after explaining it. Okay, so the shell number 1 has got only one subshell, that is S. S is represented by 1s. So the shell number 1 will come before the subshell representation S. Then another example is shown here, P subshell, which is present in the shell 3. So 3 will come before P. So that is represented by 3P. Then D subshell, which is present in the 4th shell, which is represented by 4D. Hope it is clear. Then the other subshells that needs to be filled, we will fill now. S subshell, which is present in the shell number 2, we can say it is 2s. Then P subshell in shell number 2, that is 2p. Then S in shell number 3, 3s. 3p is already there. Then 3d. Then we will go to the shell number 4. So S subshell, which is present there, that is represented by 4s. Then P by 4b. 4d is already filled, and 4f. Hope it is clear now how to represent subshells in each shell. Then we will see what are the number of electrons that can be accommodated in each subshell. We have already seen number of orbitals that is there in each subshell. And we also know that number of electrons that can be accommodated in an orbital is maximum 2. So subshell S, there are 1 orbital present. So 1 into 2, 2. 2 is the maximum number of electrons that can be accommodated in subshell S. In subshell P, number of orbitals are 3. Therefore 3 into 2, 6. 6 is the maximum number of electrons that can be accommodated in P subshell. Then in D subshell, 5 into 2, 10. And in F subshell, number of orbitals 7. Therefore 14 electrons maximum. Okay. Now we will see how to fill electrons in the subshell. The electrons are filled in the shells in the increasing order of their energy. That is, K will be filled first, then L, then M, then N. Likewise, when the electrons in an atom are distributed in the subshells, we know that subshells are there inside the shell. So electrons inside the subshells are also filled in the increasing order of energies of subshells. That increasing order of energies of shells and subshells are shown in this figure. K will fill first, then L, then M, then N. Inside K, only S is there. That is represented by 1s. So 1s is having the lowest energy. Then in the L, 2s will be filled first, then 2p. Okay, L is number 2 shell and M is number 3 shell. So then comes 3s, 3p and 3d. Then in the N shell number 4, 4s, 4p, 4d and 4f. 4d and 4f, 4f is not shown here. Okay, and another thing that should be noted is 4s is having less energy compared to 3d. So in the electronic structure, we can see first 4s will be filled before 3d. Okay, in this graph, we can see the increasing energy from n equal to 1 to 4. The lowest energy shell is n equal to 1. There, 1s is present. So the 2 electrons can be accommodated in that 1s. Then the next 2 electrons will go to 2s. And the next 6 electrons, maximum 6 electrons can be accommodated in p. So next 6 electrons will go to 2p. Then 3s, 2 electrons will go to 3s. Then the next 6 electrons will go to 3p. After 3p, 4s is coming because 3d is having higher energy compared to 4s. So 4s, 2 electrons. Then in d subshell, we know that maximum 10 electrons can be accommodated. Therefore, next 10 electrons will be accommodated in 3d. Then next 6 electrons will go to 4p. So in this way, electrons will be filled inside the atom. We'll see some examples. One example is common example is carbon. We know that atomic number of carbon is 6. So first 2 electrons will go to the 1s level, that is represented by 1s2 here. The next 2 electrons will go to 2s level, so that will be filled, so that is given by 2s2. Then the next 2 electrons will go to 2p level. Only 2 electrons are there, that 2 will go to 2p, so 2p2. So 6 electrons are filled in this way, 1s2, 2s2 and 2p2. Another example, hydrogen. Hydrogen is having atomic number 1. Atomic number 1, only 1 electron is there, that will go to the first shell and first subshell, that is 1s. Only 1 electron is there, so we will represent that by 1s1. Okay. Then helium, 2 electrons are there, so that will go to the first shell and first subshell. So those 2 electrons go to 1s subshell, and that is represented by 1s2. Okay, so this is hydrogen, this is helium. Okay, so we will see some more examples here. Some of the common elements and their electronic configuration and according to the atomic number. Hydrogen, we have already seen 1s1. Helium, we have already seen 1s2. So helium fills the first shell. So it has got a stable configuration. When an element fills a particular shell completely, we say it has got a stable configuration and its reactivity will be less. Those elements are known as rare noble elements or unreactive elements. Then lithium has got atomic number 3. It has got 3 electrons. So the next electron after filling 1s2 will go to the next subshell, that is 2s. So 2s1. So 1s2, 2s1. Then beryllium 1s2, 2s2. Then carbon we have already seen. Then neon at atomic number 10. So here 10 electrons are there. First 2 electrons fill 1s. So 1s2. Next 2 electrons will fill the 2s, 2s2. Next 6 electrons will fill the 2p. So 2p subshell is filled, as well as n equal to 2 shell is also filled. So 1s to 2s to 2p6. So since that shell is completely filled, it has got a stable configuration. That is why neon is known as a stable element or noble element. Then sodium, magnesium, aluminium. Again, argon having atomic number 18, it has got 18 electrons. So after filling 1s to 2s to 2p6 and 3s2, next 3p6 also filled. So n equal to 3 shell is completely filled in the case of argon. So it has also got stable configuration. Then after 4s, for 3D coming, okay, for other elements that we can see in the higher order elements, with the higher atomic number. So this is the atomic structure representation of Bohr atom model. Hope you have understood. Thank you.